Hey everyone, it's Mr. H here. We're going to jump right into section 5.1, which is the beginning of trigonometry for this textbook. The first part of the textbook is on college algebra. So we're starting here. So I just put a little paragraph about what trigonometry means to get us started here. So just the word trigonometry, it really is derived from triangle, trigon, and then metry is the measurement. So triangle measurements. So we're dealing a lot with calculations within triangles, which deal with sides and angles and that sort of thing. Okay. The cool thing about trig is it has a lot of applications in various fields. I listed some here, and I also listed a link there if you're interested in more about where you see trigonometry. Check out that link. That's where I stole that paragraph as well. So it's not my original paragraph here. Anyway, let's jump right into some basic terminology. We're starting with angles. So to generate an angle, you first start with a line, right? So a line is determined by 2 points, right? So notice the arrows at the ends. It's a never-ending continuous line going through 2 points. If we say line segment, so that just means the points or the line's going to end at those 2 points, so no arrows. And then finally, a ray, you'll see a point on one side and an arrow on the other. And that's what we're going to use to generate an angle or create an angle. So an angle consists of two rays and then with a common endpoint. And that common endpoint is called a vertex. So there's your common endpoint there. And then we have our two rays. Now notice how we are describing them. We're going to talk about an initial side, kind of where the angle starts. And oftentimes in this class, we'll be using the Cartesian plane, positive x-axis. That's where we'll start our angles just for consistency. And then we sweep another ray to a certain distance, and that's going to be the terminal side. And that creates some sort of angle here. Let's color it in. There's your angle, right? And then the size of that angle we can describe, try to come up with some ways to talk about the size of the angle, all right, and which we'll get to next. So on our next page here, you're going to see in this class positive angles and negative angles. What? So a positive angle just means we're rotating that terminal side in a counterclockwise direction. Okay. And then if you go the other way, a negative angle is going to be clockwise, going that way, going down and around. Okay. Now, the most common unit of measurement for angles, you probably have heard it, is the degree, right? This page up here. So a complete rotation, if we go all the way around and our terminal side is the same spot as the initial side, that will be an angle of measured 360 degrees. Probably have heard that before. Now, where does 360 come from? I mean, somebody just decided to use that number at some point when trigonometry was being sort of developed. But 360 is a pretty nice number. It's divisible by a lot of other numbers like 2, 3, 4, 5, 6. So if you don't have a calculator, which is probably when this was invented, you use a nice number like 360. Also 360 by coincidence, it's the number of days in a year approximately, right? So since trigonometry was used in astronomical studies, might have a relationship there. But anyway, 360 is one full rotation. That's what you got to know. And so if it's 1/360th, if the angle is just 1/360th, that's 1 degree, right? So 1 degree is pretty tiny, right? It's just 1/360th of a full revolution. Okay. Some special classifications of angles. So just some other terminology here. If we say acute, that's somewhere between 0 and 90 degrees, right? A right angle is exactly 90, and there's the picture. Oftentimes we'll use that little box in the corner to represent that. Obtuse is past 90, but not past 180. and then a straight angle is exactly 180 degrees. Okay, so let's practice with some degree measure. A good way to do that is just use a clock. So this one says find the measure of the smaller angle formed by the hands on the clock. Okay, so let's just do an example of, say, let's say it's 4 o'clock. All right, there's my hands. There are my hands. And so we want to find the smaller angle, which would be that side. What is the measure of that angle in degrees? Okay, so we're going to use the fact that one full rotation is 360. And then in a clock, I know there's these little 5-minute segments. There's 12 of them. So I could take 360 degrees, divide that by 12, and that's 30 degrees, right? So each of those 5-minute intervals is 30 degrees. And if I count them, 1, 2, 3, there's 4 of those in my angle. So I would take 30 degrees, multiply that by 4 to get 120. Final answer. Okay, so that's pretty much it, right? And really what you're doing there is just getting used to degree measure and what it looks like. I guess we could try another one, 10 o'clock or something. Ooh, it's getting late, right? Past my bedtime. Okay, so what would that degree measure be? Okay, I see that there are 2 5-minute intervals. And again, I know each 5-minute interval is 30 degrees. So I would just take 30 degrees times 2 for that one. That's a little 60-degree angle. And that's it. Okay, let's move on. The next thing is degrees, minutes, and seconds, or sometimes referred to as DMS form. That you'll see used in navigation a lot of times, latitudes and longitudes. Really what it is, it's a system for even breaking down a degree into smaller units, right? So a degree is maybe kind of large when you start talking about the Earth. So we want to break it down into even smaller units of measurement. So let's take an example to explore that. The latitude of New Orleans is given in DMS form as that. It's 29 degrees, 57 minutes, and then 3.834 seconds north of the equator. Okay, so that's this angle right here, right? So here's New Orleans on the Earth. There's the equator, right? So if you kind of cut the Earth, right, to the center of the Earth, the angle that New Orleans makes with the equator is about 30 degrees, right? A little less than 30 degrees, okay? So this gives a precise location, right? If we didn't have minutes and seconds and we just said 30, it's not going to be quite precise. So this gives us that precise location. You could also give it in just decimal form, right? It's the same as 29.95, etc. degrees north, okay? So what you'll want to be able to do is convert between that DMS form and the decimal form. In order to do that, you need some conversions. And so that's what's listed below here. So a minute is defined as 1/60th of a degree, or in other words, 1 minute is 1/60th of a degree. And this will probably be useful. So 60 minutes is 1 degree. Okay, so you can think of a degree as like an hour, if you want to remember that. 60 minutes in an hour. Okay, and then a second is 1/60th of a minute, right? So that therefore 60 seconds equals 1 minute. That's the same as time, so that's helpful. Okay, so you're just breaking that angle of 1 minute into 60 equal parts. These angles start getting really tiny. Okay, and then one final conversion. So a second as a degree. Well, 60 times 60 is 3,600. So there are 3,600 seconds in a single degree. Okay, so think of an angle of a degree and then cut that into equal parts, 3,600 equal parts. Each one of those is a second. All right, so let's do some math here. Let's convert the latitude of New Orleans from DMS form to decimal form. Okay, so I go back, get my DMS form. There it is. right? I want to convert that into that, right? That's my goal here. Okay, so notice the 29 is not going to change, right? That's the whole degree. We're good with that. Okay, so it's that's going to be consistent. So what I'm going to start with is that 57 minutes, right? So when I go down to my work here, I know it's going to be 29, and I'm going to use plus, right? How can I change 57 minutes into a degree? And I'm going to use this conversion here, right? So I'm going to take 57 and divide it by 60. Right? That's the fraction of a degree, 57/60ths of a degree. Okay. And then I'm going to do the same thing for seconds. So if I go back up, the number of seconds there is 3.834. So sorry for all the scrolling. 3.834. I want to convert that to degrees as well. And now I have to use this, right? So there's 3,600 seconds in a degree. So I'm going to divide that number by 3,600. Okay. And then there's my calculation. So now I'm going to my calculator. You can't see me do it, but I am typing numbers into a calculator right now. Okay. As I do this, just, again, some little advice here. It might be nice, and you probably have this going already, to have the notes that I'm using printed out and in front of you, and you can just follow along and write down your own notes as we go. That would be helpful for you. Okay. So these notes will be really helpful when you get to the homework. You'll see similar problems. Okay, so notice if you are doing the calculation in your calculator, to maybe check me, I get 29.951065. Right? 29.951065, which is what it should be, because that's what it had on the internet when I looked it up. So they were right. Okay. How about the other way? If I want to start with the degrees and convert that to DMS form. Let's try it out. Okay, so again, I know it's the 29 degrees. The whole degree is not going to change. So I'm going to start with that decimal portion, 0.951065. I want to convert that to minutes. To do that, multiply by 60. Okay, so if I take that fraction of a degree, multiply it by 60, that'll be minutes, right? So I'm going back to my calculator. And that's 57.0639. Okay, so now I've got 29 degrees and 57.0639 minutes. Okay, that's cool. And that's an accurate answer. That's just in, I guess, DM form, degrees and minutes. But I do have a smaller unit of measurement, seconds. So now I'm going to take 29, 57, those are good. And now take this new decimal portion, 0.0639, and convert that into seconds. Now this is minutes into seconds, not degrees into seconds. So I'm gonna have to use that conversion right there, right? There's 60 seconds in a minute. So I'm gonna multiply this by 60 again, and that'll give me the number of seconds. And this will be my final answer. So my final answer is 29 degrees, 57 minutes, and then whatever that calculates out to be, let's check it out, 0.0639 times 60, and that's 3.834. 3.834 minutes, final, okay, which is what we started with. So that is accurate, okay? So that's your little technique for going back and forth between DMS form and decimal form. All right, and so there's a good place to stop at this point and try to make these videos just about 15 minutes. And the next video will start up at page 4. Okay, hope all's well with you. Take care. Talk to you next time.